Okay, good morning and welcome to lecture number 30. In the last lecture, we looked at heaps. Sorry. Okay. Heaps. So we defined heap as a data structure over arrays. So these are trees implicitly represented over arrays. So the order restrictions are two types. One is max heap and min heap. Min heap. So we need to support operations such as heapify. So for in the case of max heap, we call it as max heapify. In the case of min heap, it's called min heapify. It's basically given a node. We assume that the heap or subtree below it are both heaps. That is, both of the children are heaps. But whereas the given node might be violating, we saw that that can be done in order of log n time. Given an array of n elements, we need to build max heap or dually min heap. So we saw that that can be done in order of n time. Given an element, insert that element into a heap. That also, in the worst case, can be done in order of log n time. Similarly, if you want to extract the maximum element from a max heap, similarly extract the minimum element from max min heap, it's basically removing the root element. So that we saw that it can be done in order of log n time without much details. There are also other operations which are needed, in particular when we use heaps to implement, say, for example, priority queues. So here the operation in the case of max heap, it is called increase key. In the case of min heaps, it's called decrease key. Though the routine can be modified to reflect arbitrary change in key rather than increase or decrease, but in the case of priority queues, I mean, that is what is relevant. If it is max heap, so you increase the maximum priority queue, you increase the priority. If it is minimum, you again, I mean, either way you increase the priority. Okay, so that again can be done in order of log n time. All we need to do is change the value and then apply heapify procedure. Okay, so yeah, so today we are going to, yeah, so this is a summary again. I just took it from CLRS. So these are the operations. So if you want to find minimum, it can be done in order of n time. In fact, theta of n time, you cannot do any better. But if you want to extract minimum, that is remove the minimum element from the heap, it requires order of log n time. Okay. So union is an operation we didn't consider. It's basically given two heaps, you need to merge into a single heap. Okay, so that's a union operation, just like what we did in disjoint set union. Yeah, so deletion is deleting a particular element from the heap. Okay. So today we are going to use these heaps in the implementation of Prim's algorithm. So for that we need the notion of priority queues. Okay, so the heap structure immediately gives us implementation for priority queues. I just yeah. So this is something that we didn't do completely in the last lecture. So I'll just leave it to as an exercise to write detailed procedures for max heap insert, heap extract max, and heap increase key. So similarly do the same for min heap. So one quick question, those who are doing advanced programming lab, have you implemented heaps already?
No, sir.
No. Okay. Is it going to come or no? You have no idea. It's only algorithm implementation there, is it?
No idea, sir.
No idea. Okay, okay, fine. Yeah. Okay, so even if it is not, I just would be happy if you try out writing the procedures and also writing actual programs. Okay. Yeah. So min heap is basically dual object. So dual to max heaps. So the root element has minimum value or is the minimum. Okay. So everything else, almost all other procedures, they basically go through. Only thing is you'll have to change greater to less than, and the root element will be minimum. Okay, so you can only do extract min. So extract min instead of extract max. Okay. So what we'll do is we'll use these min heaps to implement what are known as priority queues. Okay, so yeah, I just followed CLRS to discuss only max heaps, but CLRS did it so because they were also discussing heap sort. So that is another exercise. So also read about heap sort from CLRS. Yeah, I think chapter 6. Okay. So I'm sure all of you would have seen the queue data structure in your first course on data structures. That should be in your third semester of undergrad course. Okay. So queue is a first come first serve or first in first out structure where you assume that, so the basically it's a data structure for storing data. So the assumption is whichever data which comes in first, so when you want to remove from the queue, that will be the one which will be removed first. Okay. So I mean, it's basically this comparable to the standard definition of queues. So you must have also seen queues with the priorities. So you have a queue structure where now the first in first out will not be applicable right away. Each element will also have a priority value. Okay. So the one with the say highest priority, it could be minimum value or maximum value, how you define it. Okay, so say minimum priority, so that means so minimum value, so minimum value has the highest priority. So say I have items, say x, y, z, a, b, etc. So the priority is 1 here, this is 2, this is 3, this is 4, this is say 7. Okay, so here, so this was, let's assume this is the first element, this is the last element. Okay, so this is the front and this is the rear. Okay, so when you want to remove an element, so the queue should prioritize. So that means, so the priority one element should come out, so instead of the element which arrived first. Okay, so yeah, essentially it's a data structure for maintaining a set of items, of course a finite set of items. What we assume is each item has a key associated with it. Okay, so you can imagine two kinds of priority queues. I mean, highest priority for the items which are associated with the element which is arrived first. Okay, so Hello?
Yes, sir. Now
So
you
for
are audible. Now you are audible.
for how long was I out?
About a
It
minute.
seems to be
About a minute or so.
okay. Okay, I didn't even realize. Okay, so I'm just speaking, but I don't know why I got logged out anyway. So it could be because I think. No, I think I logged in from my regular Gmail account, not the IITM account. Okay. Sorry. Okay, so in this, okay, I don't know where I was lost. So
Sir, we cannot see your screen.
you cannot see my screen. Oh, okay. Maybe Girija, you can stop the recording for a minute. I'll just log out and come in through my IITM account. Okay. So
Sure, sure.
I think it is allowing me to present only for 10 minutes or something like that. Okay. So I'll do that.
Sure. I'll stop recording.
Yeah, yeah.